So, very good afternoon to all. We have our next speaker with us, Mr. Supreet Singh. He is working as assistant professor in the Department of ECE at Baba Banda Singh Bahadur Engineering College, Punjab. He has more than 15 years of teaching experience. His areas of interest are wireless communication, embedded programming, intelligent cognitive wireless systems, and embedded systems. He has more than 20 publications in national and international conferences as well as an international refereed journal. Currently, he is doing his research work in the field of 5G wireless systems and embedded systems. So today he will give us about the introduction about Android platform and the use of this Android in the development of embedded systems. So I welcome you, sir, in this session.
Thank you, ma'am. So uh, today I'm going to give you a brief introduction about Android systems that are used in embedded systems. Right. So Android platform, embedded systems, because we are quite familiar with the Android. You use the so you are all familiar with the Android system. You all use smartphones nowadays. So, but how it was developed, what are its architecture and underlying principle of operation, right? Main technical, how it's going to operate. So that I'm going to tell you. So Android system in embedded systems, Android platform in embedded systems. So first of all, I'll just give the introduction about an embedded system, right? So I'll just revise out what's an embedded system. So that's the embedded system is that is standalone. It's a chip that includes all CPU is right that's connected to sensors, actuators, which are all operating in real time, but they are programmed once or they may be reprogrammable, right? So embedded systems means the system embedded in a chip, right? So system that is embedded into one microcomputer, very small chips, right? Now you operate on mobile phones, so a lot of system that is integrated into very very small chips, right? So we have microcomputer, PCs, printers, disk drives. These are not embedded systems. Right? So, like a system that is programmed for particular purpose, that is embedded system. Right? For particular, like ATM machine, right? Like the systems nowadays in intelligent cars, those are embedded systems. So, so let's have a small introduction. Now, definition of embedded systems. There's a combination of hardware and software which together forms a component of larger machine. That's embedded system, right? So uh, no, we have larger machine. It can be any system, mobile system, missile system. It can be anything. So underlying the system, the working is by hardware, right? So the intelligence is being performed by software. So example is like microprocessor that controls an automobile engine, embedded system that is designed to run its own without human intervention, that are intelligent systems. So they may be required to respond to events in real time, right? So all these are the embedded systems. So application areas in our daily life. So can we guess any application areas that we use in our daily life? Washing machines, mobile phones, washing machines, cars, right? Then microwave ovens, right? So nowadays, all the in all almost all the applications in all the products we are using embedded systems. So the typical applications include TV remote control nowadays. So there are stereo phones, refrigerators, microwaves, washing machines. So the lot of the systems, alarm clocks, right? So we have electronic toys, very small toys, PDAs, electronic musical instruments, all they have embedded systems. Even a small toy which a child play. So there's a lot of system embedded into this, right? So these are typical areas. And not only this, The list is unending because automation is involved nowadays in everything. So we have medical systems, patient monitoring systems, ingestion systems, sorry, so office equipments, they're all embedded systems like tools, multimeter, oscilloscope, which are being used in labs. They're also embedded systems. ATM machines. Then for transportation, we have planes, trains, boats, radars, traffic lights. Nowadays, all the system that is being automated and digitally operated. Right. So there's a microprocessor involved. Sorry. So these are all the application areas: automobile, engine management, trip computer, cruise control, car alarms, so building systems, elevators, heaters, air conditioning systems. Then we have in agriculture, in space. So everywhere, whatever, wherever there's a automation involved, there's embedded system. Right. Embedded means the system that is embedded. Right now, we can understand this as a like our biological system. Person has we have a hardware, but the intelligence is embedded into the brain. Right? That's embedded inside. So just by seeing, we can't tell what is the intelligence. Right? So similarly, hardware is very small part, and the system which is embedded into that hardware, that is embedded system, kind of software, reprogrammable or whatever you see. Okay, let us take the example of automobile. How many embedded systems are there in modern car, or how many you expect? We have trip computer, electronic ignition, airbags are there, keyless entries are there, ABS or so on. All the systems are automated with the sensors. So how many systems, how many sensors do you expect in a modern car? There, right. So like this, it has more than 85 sensors of 40 different types. Right. So different sensors working different for different purpose. And right. So there's again embedded system, example of embedded system. So now let's come to Android platform. Now Android was developed by Google, we all know. It was developed for mobile devices which operate on wireless systems. Right. So Android is a software stack. It's not actual operating system. It's a software stack for mobile devices that includes an operating system, a middleware, and key applications. So we'll just see throughout my talk. I'll be discussing the basic architecture of Android system. What are tools required if I operate, if I want to have my own system based on Android. I want to have my own mobile phone system in the lab, right? Because nowadays it is very easy, right? ARM kits are available in the labs readily. So we can make that it's very easy. So just interfacing, because Android is open software, right? It's not licensed like iPhone, iOS, or any other Windows. Also, all licensing requirements are there. So Android is freeware. It's a free platform, open source. If you know the programming, so you can customize it according to your own requirements. So it's a software stack for mobile devices that includes operating system, middleware, and key applications. So these key applications are customized, right? They are based on based on the application, right? Based on the interface, hardware interface that we are using. So just brief history of this. So we have in 2005 Google acquired Android inclusives to start Android platform. Then it was a work on DVM, Dalvik virtual machine. So all Android system that uses DVM, Dalvik virtual machines, parallel to JVM. You might have seen or used JVM, that is Java virtual machine. In all the games, whenever we install games or whenever we play games on a PC, so we have JVM, Java virtual machine, right? Through that. So on parallel lines, there's a DVM, Dalvik virtual machines. In 2007, there was a Handset alliance So there was a SDK, that's a software development toolkit for the Android. So there is a first Android available in 2008, that is version 1. We'll also see what are different versions nowadays up to now, how much versions have been released and what were the add-ons in each version. So this is a first mobile phone. At that time only iOS by Apple was available, and this was the second system by Google which supported the smartphone. In 2K9, then it was uh, SDK 1.5, was next version, 1.6 next version, then another, that is in 2K10 there was SDK 2.0. So then, and more releases were there in the subsequent years, and that we'll see as we proceed. Now Android system is an open source operating system created by Google specifically for use on mobile devices like cell phones or tablets. Now it is based on Linux. So we all have Linux, right? Nowadays, Linux is a open source, and just uh, discussing uh, tidbits of Linux. Right? So Linux operating system is an open source operating system, right? So which is all derived on C and C++. Linux kernel, that's all derived in C and C++. It was started only as a project. So this Linux was started as a final year BTech project by some engineering students, and they developed few libraries and again add on. So we had a full system, a standalone system, Linux operating system at one stage. So there's all open source and run in C++. Nowadays we have different versions like Ubuntu, Fedora, and so on. There are many versions. Red Hat, Linux. Now this is the base of Android. Right? So Linux kernel is used in Android system to interface hardware and upper layers. So to interface hardware with the upper layers, to communicate hardware with the upper layers of network devices, we have Linux kernel as a base for the Android system. Right. So this is readily available freeware. We can freely download on the internet, and Android system is also we can freely download on the internet and make a new application. Right. So now this is a Linux based. Can be programmed in C, C++, but most we have two types of interfaces in Linux. So we have a C, C++ and Java. So both languages can be used to develop an application in Android as well as in Linux. So Android is based on Linux kernel OS, so which is used for hardware. Now you know what is kernel? Kernel क्या होता है? So kernel is actually the basic libraries, like we can say our hex file. Hex file is a type of kernel because it directly interfaces with the hardware. It tells the hardware what to do, right? So it tells the hardware what to do, right? So like a hex file, right? So the underlying program that we say it's a kernel, right? So a group of programs, so specified for a particular system to operate particular system in the different environment. So that's a kernel. You have Linux kernel. So it can be programmed in C, C++, but most of the apps they are done in Java. So then we have Java to C interface that was done. So which needed the support of Bluetooth, Wi-Fi, 3G, 4G networking, all that is available. Right. So that's done in Android system. So it's an open source operating system. So what we have learned right now is Android is an open source operating system created by Google specifically for use on mobile phones, on network devices, cell phones or tablets. So it's a Linux based kernel. It can be programmed in C, C++, but most applications development is done in Java. Then sports, Bluetooth, Wi-Fi, 3G, 4G, networking, right, and so on. Many applications nowadays are based on Android system. So just before the previous slide, we talked about Open Handset Alliance that was made by Google to the Android version. So to compete with Apple's iOS, so we had an alliance of 47 companies to develop open standards for mobile phones. So there were semiconductor companies, there were mobile operators, there were software companies, there were handset manufacturers, so commercialization companies. So all they made an alliance to develop Android system in 2K7. So nowadays we have STCs, whatever mobile phone, you name it, that operates an Android system. So these are mobile phones, some of the mobile phones that were developed in the first version. First version was in 2K7 or 2K8. Right. So a lot before these were developed on version 1, on version 2. So Sony Ericsson developed its own, then Velocity Micro. So the devices I'm showing to you, they were version 1. They were operated on version 1 Android. So may not be available nowadays. So let us see the differences, some of the differences between Android and iPhone. iPhone operating system is iOS, that is proprietary. Android system is open source. That's not, we say it's an operating system because it interface the hardware and software, but in actual sense it's not an interface, right? So OS is, it's a proprietary, OS is an open source in case of Android. So OS, iOS by iPhone, by Apple, it runs on iPhone and iPod touches only, but OS can be licensed for any mobile phone device. The apps are written basically in C or Objective-C language in iPhone, whereas apps are written in Java language in Android system. So development tools are available. They are available in Mac OS only, whereas development tools are available in many OS in case of Android. Then we have Apple that must approve all the applications to upload on the application store, whereas for Android no approval is required for apps to upload on the Android market. This Android market was the name of Google Play Store when it was firstly developed, right? So in 2000, after 2010, Android market was renamed as Google Play Store when it acquired most of the companies in the alliance. Now in Apple OS, in iOS, some applications are more important than others. That is, some priority is given, whereas in Android case, all apps are considered equal. That is, we choose our own browser. We can choose my own application, any application. So they're all equal. So these are key differences between iOS used in iPhones by Apple and Android. So the internal differences, apps are written in iPhone, they are in C language, whereas apps are written in Java in Android case. So again, I'm coming to the basic of the Android. So it's a software stack for mobile devices that includes an operating system, middleware, and key applications. So it provides It uses the Linux to provide the core system services like security, memory management, process management, power management, and few of the hardware devices. So most of the services, these services are being used by the Android, which are inherited from the Linux kernel. So let us discuss the underlying architecture. So this is just a basic that how it operates. It's just a software stack. We say it's a operating system. In actual sense, it's a software stack, right? So there is a part of operating system, middleware, and key applications, right? So before developing any application for embedded systems, we must know the hardware first. So let us see first the basic how any system we need to program what which it works on the hardware. It can be a microprocessor, it can be a microcontroller, any hardware. Right? So nowadays ARM kits are readily available in the lab, so we can choose those hardware. That hardware, no, hardware has to be interfaced because hardware understands only machine language. So machine language is in the form of 1010. So around this, the core libraries are developed. That is called as kernel. Any command we want to give to the hardware, we'll be giving to the kernel. So it just translates. It's like you can say it's like kernel is like a assembler. So what it does is it just converts the language or the command to the hardware machine language in the form of 0101 to operate. Then after this there's a shell part. Shell is actually a translator, and at the upper there are apps or programming part. So shell is just a translator which translates the different types of commands given as understood by the kernel. And kernel is actually giving commands to the hardware which operates or performs a particular function. For example, the certain signals are coming from the sensors and how to operate with that signal. So signal का क्या करना है? उस signal को कैसे process करना है? Like the signals are coming from, let us say, an example of our automobile system. Signals are coming from the car, so from the parking system. So how to process those systems and how to behave. So that is signals are coming to the hardware. So how to operate, how to translate as being understood by human. So that is a part of kernel and shell. Right. So now let us see from this. Let us see the architecture of Android system. So now the basic architecture we have. So basic, there are 5 layers. So we have at the top there's are applications, there are different applications. So we have home, contacts, phone, browser, and so on. There are many applications. So it may compose of many applications. So then there's application framework like activity manager, Windows manager, resource manager, right? Which application is taking, there's a resource manager, then how much hardware requirements are there. Android system is a 5-layer system. Application part, then application framework part, libraries, Android run, and Linux kernel. So there are 5 parts. We have, again I'm repeating, application. At the application part, we have many applications. An application framework, there's activity manager, window manager, viewing system, package manager, telephony manager, resource manager. So we are going to discuss this all these layers one by one in detail. Another, there's a libraries. In libraries, there's a SGL, SSL libraries are there. WebKit is there, right? Media framework is there. Surface Manager is there. So there are different libraries. Then there's a Android runtime. There's a core libraries along with a DVM. There's a Dalvik virtual machine. I just told you before. We will discuss this in our upcoming slides in detail. What is DVM that I'm going to discuss? Then at the last, there's a Linux kernel. So Linux kernel is actually the system which interacts with the hardware. So we have here display driver, camera driver, flash memory driver, audio drivers, Wi-Fi driver, and so on, power management. So all this is in the Linux kernel. Now let us discuss all these layers one by one. Before discussing, application part is now just there's a we have two types of tools, right? One is to develop the applications, another is to develop the platform itself. So all architecture that is divided into two parts. One is application part and platform part. Right. So starting from the top application. So here we can see it's not a type of operating system. Android is not clearly an operating system. It has few characteristics of OS, but in real sense it's not. It's only a software stack. So different softwares, different libraries are working and they are passing messages to each other. So we have here Android software stack. Let us discuss one by one. We have application layer. So we have home, contacts, phone, browsers, the core applications. So Android provides a set of core applications: email client, SMS programs, calendar, maps, browser, contacts. Now all by parts they have been developed by Google. They are not freeware. Android system is open source and freeware, but these applications are not freeware. Now if I want to develop my own system, I can download Android system. I can install Android system on my ARM processor in the lab, but these applications may not be provided. No application is provided. Right? It's a core system which is freeware. But if I want to use these applications, customize these applications, I need to take permission, I need to take license from the Google. Right? So therefore only the core system is freeware, but applications are not freeware. Right? So though when we purchase a device, so that company has already an agreement with the Google to install those applications, Google applications. So that's why it's providing us navigation, GPS, or so on, many different applications on a system, right? Because it has already an agreement. Right? Otherwise, because Android is freeware, anybody can use. Anybody having a knowledge of installing Android, I'll just explain tidbits of the installation, how Android can be installed in a lab, and how it works. So before that, I just need to go through the architecture, the underlying architecture. So Android system, it provides a set of core applications: email client, calendar, maps, browser, and so on. There are many applications. All they are written in Java language. So this was the application part. So let's come to next layer. There's a application framework. So we have here activity manager, window manager. Now applications provide the interface to the user, but application framework, it provides the activity information of the user to the OS, to the down layers. So what are the activities we are performing, right? So whatever the commands we are going to our smartphone, the commands we are giving to our embedded system. So the application is only processing. That's only passing the commands, but the work is being passed to the application framework. That's the underlying framework of the Google. So we have activity manager, Windows manager, content providers, system, package manager, telephony manager, resource manager, so notification manager. So there are different parts which have been developed in a C++ and Java language combined. So a few parts have been developed in C++ and few parts they are in a Java. So it just enables and simplifying the reuse of components. Developers have full access to the same frameworks, APIs, application programming interfaces used by core applications, and users are also allowed to replace the components. So we have updations. The notifications come from notification manager. Right. So the location part, GPS system, that is handled by the location manager. So there are separate parts in the application framework. So telephony manager, then we have resource manager. So different resources, they are to be optimized, right? So what are the memory being used by the different programs, the resources, the CPU power or memory management, all that is done. Actual sense, it is not done. It is the memory management information is passed to the down layers, right? So this application framework only tells that which application requires how much memory. So the second layer, there's a application framework. Next is our now the main features. Let us see what the application framework. So we have view system that is used to build an application, including lists, grids, text boxes, buttons. So whatever web browser, whatever information is there, what we are seeing on our mobile phone. So that is a part of application, right? So that is handled in the application framework by view system. How the application will be viewed by the user. Another is content provider. So it enables the applications to access data from other applications or to share their own data. Right. So what we have is content provider. What it does is it just picks up the different types of contents from where to fetch the contents, like from the internet, where from the internet, right? Particular locations, different locations. There's a list, full list. This content is being accessed from this. These contents are being required by this. So there's a full list in the content provider, right, inside. Then we have resource manager. So again, in the resource manager, it provides access to known code resources, strings, internal graphics being used, right? So now we can customize this. So we can customize this resource manager as per requirement. Even different companies nowadays, they just take out the Android, they download the Android system, open source is there. So they download this from the internet, from the Google website, from the Google. Then what they do is they just have their own resource manager, right? Nowadays, how the different companies, new companies, in very short time, they're floating their different products very fast. How? What they have is nothing. Just they have ARM processors, ARM 9 or whatever, right? Different processors readily available in a discrete form. They do nothing. Just interfacing. Interface this RAM, interface this ROM, right? Then what else? LCD is available in the market, right? Touch is available in the market. Just interface, and they just do the resource management. They just customize as per their own. They make their own logo and make few applications and just float that product in the market. Nothing else, right? So even you will see in most of different companies products, there's only difference in the resources. This having different processor, another company having different RAM, different ROM, only this, nothing much. Or a different category in the, you can say, in they just do optimization, right? Optimization of resources, right? Again by the resource manager, customize the resource manager. So providing access to known code resources, localized strings. I'm just reading graphics and layout files. Next is we have notification manager. Now this notification manager enables all the applications to display customer alerts in the status bar. So what to do, how to do, what activity is required, so in which state our system is operating. So I'm not talking about only our mobile phone, because whenever we talk about Android, our mind is there. I'm talking about any general product. Nowadays, specifically in India, we have only Android-based mobile phones. But when you can see the internet, Android-based washing machines are already there. Android-based microwave ovens are already there in the market, right? So Android-based home automation systems are already there, right? So being although they are not popular in India, but they are already in the market, right? So notification manager is there, enabling all applications to display customer alerts in their status bar. Activity manager, it manages the life cycle of applications and providing a common navigation backstack. Right. So what are the activities they are being performed? So activities, what are the different activities the user is performing? So that is all handled by activity manager. Similar in the Windows also. So whenever we click uh, at any item, that is being recorded as a log in the window. Right. We click, even a single click is recorded, single activity is recorded in the window, in Windows operating system, because we are all familiar with the Windows operating system in our PCs. We normally operate. So what we have is so normally all the clicks. Now there is also notification manager in Windows. Now let us see how it works in the Windows. This notification manager, resource manager, that is the idea is being taken from the Windows, right? So let us see how it works. Whenever I click, you must have seen. Whenever I click a particular item on the Windows, right? So there's a time I just click and response from the hardware, actual hardware. So whenever I perform any activity, I'm just talking about our normal PCs. Whenever I perform any click or any activity in the normal, what happens? There's a time frame that it has to, the hardware and OS has to pass the information to the hardware, and the hardware has to respond to my click. Right? There's a you can say timer starts. You might have noticed many times we have the system is not responding, wait or continue, right? Because how it comes? Because there's a timer, internal timer starts with every click. Right? So similarly here, so we have notification, resource manager, and of the similar kind. Whenever we press any key, whenever we perform any activity, so there is a notification by the shell to the kernel and correspondingly to the hardware, internal hardware. The command is sent, right? So depending upon it checks all the system. Then depending upon different resources available, different resources being used by different applications, so it allocates the resources to the particular applications, right? So this all is done in application framework in Android. So let's move next in the next stack. So again, down the stack we have libraries. So we have Surface Manager, then Media Framework, SGL, SSL libraries are there. So these libraries are performed. These libraries, they just perform the work of translator. They get the input from the application framework and they just translate the different activities and give the output to the Linux kernel. Or okay, so uh, they just pass on the information to the Linux kernel. So as well as they also pass on the information to the upper layers. So there's a both way. So it's a both way. So it passes the information to the upper layers as well as it passes the information to the lower layers. So we have it including a set of C++ libraries used by components of Android system. So these libraries are again freeware. They have been developed in C++. They can be developed in C++ or in Java. Right. So exposed to developers through Android application framework. So application framework, it just interfaces the application to the libraries. So next is Android runtime. So I'll discuss this in much more detail. Android runtime consists of two parts: core libraries and Dalvik virtual machine. That is DVM. That was the system that I was talking about before. That is DVM. In the definition we just saw, is based on DVM, Dalvik virtual machine. So core libraries and DVM. So it's corresponding to JVM, that is Java virtual machine, that we install during any if I want to play in games. We have JVMs, Java virtual machine, runtime Java, to be installed on PCs. So these core libraries provide the functionality for the Java language, like data structures, which type of data structures, linkages are to be used, utilities, network access, graphics. So the core libraries providing most of the functionality available in core libraries of the Java language. Then we have APIs, data structures, utilities, file access, network access, graphics, etc. So all this is a part of core libraries. Now this DVM, there's a Dalvik virtual machine. It provides an environment on which every Android application runs. So it provides an environment. Like for example, our Windows, it provides a desktop environment on which our any or every application opens. Similar to that, DVM provides an environment to every application. That we say now in Windows OS, we say there's a desktop. In Android, in technical language, that we say is DVM, Dalvik virtual machine. So each Android application runs its own process with its own instance of DVM, that is Dalvik virtual machine. So this DVM is written in such a way that device can run multiple virtual machines efficiently. Right? Now, whenever we click on any application, whenever different applications run, multi-user or you can say threading. Right? So each process is given a particular ID. So there's a work of DVM. Whatever different resources they are to be given, what are the different resources that are to be used by the different applications. So that's why provided by DVM in the Android. So providing environment on which every Android application runs, each Android environment on which every Android providing environment on which every Android application runs. Each Android application runs its own process, its own instance of DVM. So it's a register-based virtual machine, DVM. Now here in DVM, the files or libraries which are written, so they have extension as .dex. In Java, we had extension of .java, and when the Java was made object-oriented or different libraries are written in Java, so it is converted to .class. So whatever we write in Java, whatever programs we write in Java, so the extension is .class. And what we have when we transfer that, when we translate that in Android, so in DVM we have .dex. So now let us have a look on DVM. Dalvik virtual machine executes the Dalvik executables, that is .dx files format. So now this format is optimized for minimal memory footprint and compilation, because we have very limited resources in our small system. In an embedded system, we have limited resources as compared to our general purpose PC or general purpose systems. Right. So embedded systems, mostly it composed of microcontrollers, which are particularly designed to perform particular function. So we have a here .java, that is translated into .class, which is in turn translated into .dex. That's a Dalvik executable file format. So now this all DVM, unlike JVM, this all depends upon Linux kernel. Right? It's a part of Linux OS for threading, for low level memory management. That all depends on Linux kernel, because Linux was already available freeware in different forms in Ubuntu, Fedora, or so on, right? Red Hat Linux, Mandrake Linux. So Linux was readily available. That's also freeware. So here, all instead of redesigning from scratch, the Google team, the developer team, they just reused all this Linux kernel and they just customized it, worked on that, optimized all the kernel to operate on limited resources, limited hardware resources. Whether it is a, you can say, processor in terms of memory, in terms of, you can say, display, in terms of input, in terms of output. So, so this all has been customized to operate on limited resources. So Dalvik VM, let us summarize. So Android runtime consists of Dalvik virtual machine, is a subset of Java developed by Google, optimized for mobile devices, for battery, for better memory management, for optimized battery utilization, and so on. There may be many optimizations that have been done during customization. So it runs .dx files that are compiled from .class files, and also introduces some new libraries. Uh, so DVM does not support some of the Java libraries. So because it is customized into new, so it's previously as a Java virtual machine, it has been converted into DVM, Dalvik virtual machine, but it doesn't support some of the libraries that are available in Java. So another, the difference between JVM and DVM in Java virtual machine and Android's Dalvik virtual machine, the basic difference is the applications are boxed, right? So because that means the application can only access its own data, or otherwise we need to set the permissions that how much data it can access from other applications or from the shared pool, right? So by default, each app is run in its own Linux process. The process started when app's code needs to be executed. Whenever we perform any activity, the code starts. So how to respond? Then it goes to the down layers, from application layer to the application framework. So how much memory to be allocated to a particular resource? That's the work of Linux kernel and runtime libraries, which keep the you can say the pool of used and unused resources, the list of how much memory is being used by which resource, which program. So all that in detail. There's a list internal. There's a resource manager in application framework we just saw in the previous slide. Then each app runs its own Linux process. Threads can be started to handle time consuming operations. Time consuming means uh, like processing part, like for example to handle the information from the different sensors, right? Now in airplane, in normal airplane, there are more than 300 sensors are there at different parts, right? So at the same time, the input is or signal is coming from all the sensors, right? So just by sampling at different times in microseconds, all the sensors have the signals, they have to be handled somewhere, they have to be combined together to form particular decision, right? So that part, that is handled. To handle that part, there are threads, different threads at the software level, right? So at the runtime, so each process it has its own DVM by default. Each app is assigned a unique ID and permissions are set, so apps files are only visible to that app. It's very important. Now this line is very important. That is, the permissions are set so that apps files are not visible to other part. They're only visible to that part only. So this is a DVM, Dalvik virtual machine. So let's come to the kernel part, Linux kernel. So in this Linux kernel, we have display drivers, we have camera drivers, keypad drivers, Wi-Fi or some. What are the different sources available? Now, first of all, what is a driver? Driver is again a program which takes the input in normal language. Driver is a program which takes the input from a system and gives us the desired output. Like camera, it just clicks on, so all pick, then saves to the memory. So what's the resolution? What's the clarity? That's the internal. That's the image processing part, right? So digital image processing part. Then we have speech processing part available in all the nowadays in all the Android applications. So how to handle the actual hardware? Because we are at the user level, the user is seeing the pic, but actual how the signal is being handled by the photosensitive layer of the camera, or how our flash memory is working. Because again, the same thing is applies to all hardware. That is, our whether there's a flash memory in our Windows, in our PCs, or whether that memory is in our mobile phones. So it understands only machine language, 0101 language, right? So in our machine language, so the drivers are there just to make that particular system understand how my user is giving commands, right? So what are different commands my user is giving? So to understand those commands, so and to give it to the actual hardware, these are drivers. So audio drivers, power management, so how much power is being used by which processor? Because nowadays what happens, microprocessor is one part, the graphics processor is another part, the image processing part is different, speech processing part is different. So all the different systems, they have been all the system has been subdivided into subsystems. So the underlying principle is only the signal processing everywhere, right? But the application area is different. How to process the signal, that is different, right? So we have here Linux kernel. So that is again kernel that is again readily available, openware. So we have so all the Android system that relies on the Linux kernel for core system services like memory management, process management, network stack, driver model, security, and so on. So this is the part actually which provides the abstraction between the hardware and the rest of the software stack, right? So it provides a abstraction layer between the how my hardware will be working and how my software should respond, or vice versa, how my software is working or and how my hardware should respond, right? So both ways. So these are now these drivers are open source, so we can customize any drivers, we can customize our own, right? So as per our own requirement, for example, to interface 13 megapixel of camera to my ARM processor in the lab, I may be requiring to write a program in ARM processor so that my signal from the camera, it is stored in particular memory area, or how my signal is to be processed, and I need to view that signal on the display device, right? So I need to write a program, or to handle the like Wi-Fi drivers, they are readily available, audio drivers. So how to handle the signals coming from different sensors? So I can write my own drivers, right? So Linux kernels drivers are available, they're open source, right? So this is the all underlying architecture of the Android system. Right? I'm just revising. Let us summarize. It is 5-layer architecture. On the uppermost part, we have application layer. Then we have application framework layer. There are different libraries. Then we have runtime, Android runtime. Then we have Linux kernel. Right. So there's the underlying which actually interacts with the hardware and provides abstraction to the software stack. So there are different versions. So that were developed by the Google. First version came in September 2008. Then next. So actually all they were open source except version 3. All the system was open source, right? And most notable features, or you can say the improvements that were developed. So version 2, there's a exchange port upgraded, just in time compile upgraded in 2.2. Then in 2.3 we had, but up to 2.3 or 3 there was not so much popularity or usage. After it had a USB port in 3 or 3.1 version, it had particular APIs upgraded, that is application programming interface, right? So that was, so after that, so the use of this system that increased many folds. So we had then 4.0 version, 4.1, 4.2, then next we have 5. So again in subsequent years there are many versions available, right? So these are just the code names. There is a Jelly Bean, or these are just the code names given by the Google to the developers team to upgrade particular you can say only particular application areas, or you can say to upgrade the particular interfaces. They are just the code names. So next part I'm going to discuss, that is Android for embedded systems. Now I can develop all the system in my lab, right? Because nowadays in our labs, in particularly in electronics labs, we have ARM platform available, ARM boards available, right? In our graduate or postgraduate, you can say in the syllabus we have ARM programming. So how can we interface? How can I develop my own embedded system based on Android? Not for cell phone, for any application, just you name it. So any application Android can be used. So there are two main pieces required to get Android working on a embedded system. One is Android compatible Linux kernel. Another is Android platform. So the kernel is basically interface that we have just discussed, that provides an interface between the actual hardware and the software. It only provides abstraction between the actual hardware and upper layers of the software stack. So Android platform is also called AOSP, that is Android operating system open source platform. Now for Android, minimum display size required is 2.5 inches, right? So below that size it doesn't work, it doesn't support. Its APIs, application programmable interfaces and drivers, that doesn't support below this, right? So this can be, this display size or interface, it can be a both ways. Both ways means a smart display or anything else. Like smart display means a touch display which has input and output both. Now our touch screen is, it behaves as an input device as well as output device, right? So we can download Android freeware from the website is given for android.googlesource.com. There's a freely available Android platform we can download, and we can customize that to use on our own embedded system designed for our own embedded system, right? So what we have is, up to now, we have two main pieces. One is Linux kernel, Android compatible Linux kernel, and second is Android open source platform that is required. Though there are some restrictions. Now restrictions are like Android bot, that is you are just seeing here on the right top corner of the screen. Android robot, there's a green colored robot that is seen everywhere all around the things that have Android. So its role is similar like a Linux penguin. Now this we can't use because that has been proprietary by the Google. We can't use this, or neither we can customize this. We need to take the permission license. Another is Android logo. Now this logo is, again, we need to take permission from the Google to customize it. Now what happens? This is a set of letters that spell out Android that appear during the device and emulator boot up. So nowadays what happens? Whenever we purchase any product based on Android, any product, not only mobile phones, whenever we purchase any product, the logo of the company comes, because this Android logo has been customized. They customize this by taking license or particular permissions from the Google. There's a you can say agreement between the different companies to use the particular set of libraries and to customize that according to their own. So same as this, like Android Google, Android logo, they are not authorized to use that logo under any circumstance. So then, right, then there are few more restrictions that are available on the website, right, from where you can download. This is the website name given, android.googlesource.com, right. So now let us discuss how to develop an Android embedded system based on Android in our labs from the scratch. So developing an Android based embedded systems from scratch in the lab. So we all have ARM processor boards available. It can be ARM 7, it can be ARM 9. Memory chip, EEPROM, we can have 1 GB or minimum requirement is 256 MB. RAM, again we have 512 MB. The minimum requirement is 128 MB. But when this minimum requirement, what is meant by minimum requirement? Minimum requirement means only the Android will cover up that space, right? So to you can say install or to customize to use the application area, right? So to install particular applications on that system, we need somewhat more memory. So normally, typically, memory chip of 1 GB, RAM of 512 MB, so it covers the basic requirements. Then we should have in a lab a PC on which to install Android emulator v2.2, a PC with Android Studio. There is a software Android Studio, that is a SDK, software development kit, available to develop any application on Android. So display with minimum 2.5 inches size. Any other auxiliary accessories like camera, different sensors, gyrometer, accelerometer, whatever, that depends upon the application, right? Like for example, for washing machine, I want to have a Android based washing machine, or if I want to have Android based microwave oven. So in that what happens, the different sensors, whatever temperature sensor is required, right, in case of microwave oven, right, so different heating equipment is required, magnetron or so on, whatever microwave generators are there. So we need to handle the signals from those, or to pass the signal, to give the signals, to command those, or to get the signals from the sensors, right. So there is a basic requirement to develop an Android based embedded system in a lab. Now ARM 7, then emulator, I'm just repeating, Android Studio, touch display or without touch customized display, and a PC. So tools. Now there are two different set of tools for Android development. Those tools for application, one is those tools which are required for application development. Another is those tools for platform development. So there are different kinds of tools available and different kinds of tools required to develop application part, application framework, that part. And if I want to work on platform means our lower layers, that is Linux kernel. Then we have runtime libraries. Then we have core libraries, right? So to work on those, on that part, different tool set is required. To work on, you can say, applications, to work on application framework, different toolkits, different tools is required. So there are two different set of tools. One is those tools which are required for application development and application framework. And is those tools which are required for platform development, right? Like kernel, runtime, and core library set. Then there's an Android emulator that's again freely available on the internet, right? So in the emulator, there are different steps to emulate the system, but the basic system, let us see in the next slide. So emulator hardware can be ARM5 CPU, corresponding memory management unit, a 16-bit LCD display, one or more keyboards may be interfaced, a sound chip with input-output capabilities, then flash memory partitions are there, GSM modem or so on. These may be required to emulate my application developed in Android on actual hardware. For example, in lab, I have just ARM kit available. With that ARM kit, if I interface, let us say, some memory like 1 GB memory, ROM, some RAM, runtime memory, that's a RAM. Then I interface certain, let us say, some display, right? Then GSM modem or different sensors. Now, to interface all this, I need to develop my own drivers, or else I can use drivers readily available from the manufacturer, or the drivers that are the part of Linux kernel, right? There are three options. So developing on drivers, or drivers that are come from the manufacturer, or develop the drivers that are or use those drivers that are the part of Linux kernel. Then what else? Then I'll just connect all those to the PC, having Android emulator, Android Studio. Now Android Studio just develops my application. To run that application, to see the effect, to debug that, I need a runtime environment Android emulator. But there are certain limitations in the emulator. So do you know the difference between a simulator and emulator? So what's the simulation? Simulation क्या होती है? Simulation means operating in virtual environment, creating virtual environment for a particular system. For example, I want to simulate some communication model, some communication system. I just take a random bits, modulate that, transfer on the AWGN channel, or some real-time channels, Nagakami channel, relay channel, right? Then what next? We just design a receiver, for example, in MATLAB, right? So we do simulation. Simulation means we just create virtual environment and see the effect. Emulator is we see those effects on actual hardware, right? So emulation is done with the help of in many of the applications, in many of the you can say hardware nowadays, boundary scan technology is used, right? So emulation is on hardware. What happens in emulator? On emulator, I can just for example, in simulators, when I want to debug my program, हम क्या करते हैं, आई जस्ट हैव ब्रेक पॉइंट्स, एक एक लाइन को एग्जीक्यूट करके देखते हैं सेपरेटली, डिबगिंग हो जाता है, पता लग जाता है. सो आई जस्ट कम टू नो दैट कि ये लाइन को ये इनपुट जा रहा है और ये आउटपुट दे रहा है. सो दिस पर्टिकुलर माय कोड, my programming code is getting this much input and giving me this type of output, right? So what we have is, in emulator I actually connect through USB or other interface. There's a nowadays USB has been a standard. Before this there was a boundary scan technology, that was JTAG standard for debugging or emulation. JTAG is joint test access group. So what happens, in the actual hardware, there is particular JTAG bus is there, right? So I just explain here. Working emulation means working on real hardware, right? So what happens, those hardware, that part of hardware that supports the emulation, ये क्या करता है, let us say a typical microprocessor or microcontroller. So I have processing unit, I have different resistors available, I have different devices. So these are processing. Now here what we have is pins. Now what happens, because in software when we do the emulation, when we do the simulation, what happens, we can just see the different lines, right, executing one line at a time of the programming code, right? So it's very easy for software developers, but for the as electronics or communication people, it's very difficult what is going on inside our hardware के अंदर, because it is working on 1010. So 1010 कहाँ पर फंस गया या कहाँ पर रह गया, so we can't see that, right? So how to see that, there was technology that is called JTAG, the acronym for joint test access group. So joint test access group that works on boundary scanning. What happens, there's a particular bus, हम हार्डवेयर के अंदर क्या करते हैं, एक बस डिजाइन की होती है बाय द मैन्युफैक्चरर. So वो क्या करते हैं, internally that is connected to each and every peripheral part, each and every part inside a microprocessor or microcontroller, like internal cache memory, internal RAM, जितनी भी RAM है. So ये अब what I do is, there are 4 pins. One is TDI input, TDO output, another is T clock, and third is T mode. So there are 4 pins: input, output, clock, and T mode. Test mode, test clock, test data output, test data input. So हम क्या करते हैं, so we just send the signals from the PC and we can see इस RAM location में मेरा क्या चीज स्टोर है. So if this is my sensor, यहाँ पर अगर मेरा कोई सेंसर लगा, सेंसर का सिग्नल कितना आ रहा है मेरी रैम में, कितना स्टोर हो रहा है एक्चुअली में, राइट, और ये प्रोसेसिंग कहाँ पे चल रही है, वी कैन जस्ट सी ऑन द पीसी, राइट. सो ऑल दिस we can just see through these pins. I just connect these pins to the JTAG driver and then to the USB, and we can just see कि internal मेरा actual hardware के अंदर, like I have RAM और ROM और microprocessor, मेरा microprocessor एक एक step में क्या क्या कर रहा है, actual hardware में कैसे processing हो रही है, that we can see. That is the emulation, right? So another part is simulation means in virtual environment, emulation means in real-time environment, right? So that's the emulator. Android emulator means I just, when I need a new application, so I need to I just need to emulate that, test in a real time, right? How the customer will experience, how my hardware is responding to that application. So I need to emulate. There's a Android emulator available for those applications. So, but there are certain limitations that are here. There's no support for actual placing or receiving phone calls, and there's no support for USB connections. There's no support for camera, video. Just emulators, it provides basic functionality. Like for example, again, some Windows, what we do? क्या करते हैं हम? We operate that Windows in safe mode. और safe mode में क्या होता है? So only basic functionality test हो जाती है. Whether the problem is with the basic functionality or the problem is with the drivers. ये हम देखते हैं. So whether my core window kernel or shell part is corrupt, or whether my display drivers or different the problems with the drivers. So similarly here, so this emulation that only provides that whether my kernel part, core part is functioning as per my optimization or as per my algorithm that has been developed, उसके हिसाब से ये काम कर रहा है कि नहीं कर रहा, right? So it provides those functionalities only. Right? So it doesn't provide a support for different devices, doesn't determine connected state, doesn't determine the support for battery charging level or some SD cards, some Bluetooth, but it provides a basic functionality. Right? Processing being done by the my ARM processor or whatever different processors nowadays available in the market, whether it's a 32-bit processor or 62-bit processor, whatever. Right? So how my RAM, whether my RAM is interfaced properly, whether my ROM is working properly, whether you can say my display is working properly. Right? So to see just the basic functionality, we emulate the system. So setup development environment, software or you can also say software development environment. So what we have is as steps. Just if I want to develop my own software, first step is install Java development kit, Java virtual machine that provides a Java virtual machine environment, because DVM that we just discussed in your previous slides, there's a Dalvik virtual machine that only there's an upgradation version of Java virtual machine, and even though that doesn't support the previous functionality, but it requires JVK, Java development kit. Then it installs Eclipse IDE that provides an interface. Then another step is download and unpack Android SDK in the form of Android Studio. I just discussed in your previous slides. Then install Android development tools, plugin for Eclipse. Then all different install instructions are available on the website. So all this, these are different steps that are required just to develop. So after development, what we need to do is we need to emulate. So one is a software part, another is a hardware part. So software part means developing application, then application framework. So then on the hardware part becomes complete knowledge of underlying hardware architecture. So to develop a kernel, we need to have complete knowledge of hardware architecture. मेरा जो microprocessor है या microcontroller कौन सी different you can say hardware you can say communication ports को support करता है, different there are different nowadays communication, internal communication के लिए different standards हैं like SPI, I2C. I2C is inter IC communication protocol. Right? SPI is serial peripheral interface protocol that was developed by Philips. Right? So then there is another. There are many different, like just same like parallel port or serial port that was developed in the previous applications in like 8051. Right? That uses our UART or USART. Right? So similarly, if we go to PIC, PIC supports many different interfaces. Like PIC microcontroller, AVR series of microcontrollers. So the embedded systems that are based on AVR, they support many different, you can say, different interfaces. Like we have SPA interface. I just told you I2C interface, USART, UART, and parallel interface PSP. That's a parallel slave port is there, right? Then there is also you can say uh, just change signal interrupt. Like there is change some signal, it will interrupt, right? So there are many different interfaces, internal interfaces available nowadays in the microcontrollers, right? So this is all like setup development environment. So this is a just the layout of producing an Android app. We have Java code for Java, then we convert that into byte codes having a dot class extension and other class dot class extensions. They are added together to make a Dalvik exe. So again, in Dalvik exe is one part that provides runtime environment. So to provide the user interface, हमारी application दिखेगी कैसे to the user, how it will behave to the application framework in the second layer, right? So the top is application layer, second is application framework layer, just we discussed in the underlying architecture of Android. So वो कैसे behave करेगी, उसके आगे कौन कौन सी libraries access करेगी, so kernel को कैसे command देगी और कैसे how it will communicate with the kernel, it will take the commands from the kernel or it will notify to the user the different states of the hardware. So these are they are combined together. This you can say DEX file for developed by the DVM Dalvik virtual machine. It is combined with the XML and the resource lists, right? So and final there is a .apk application. So we combine this, we just change that into our runtime APKs, right? So that's how our all Android application is developed, right? So we just application now. Next is our application development components that are available. There are 4 components available. First is the activity. So basic component in the application development, there are 4 types. One is activities, services, broadcast receivers, and content providers. So first is an activity. Activity is any response or any, you can say, command given by the user to the underlying hardware or to the down layers, the core layers or other layers. So activity is a functional unit of an application which may be invoked by another activity or it has a user interface of some form. Application may incorporate a number of activities. One activity may be nominated as a default, which means it may be directly executed by the user. So this is an activity part. This is the first part. Another is a service part. That's a service that is similar to the activity. No, activity comes at the application part that we just whatever we discussed, the 5-layer model of Android application. Activity is based on application part. So उसने activity ने service क्या provide करनी, कैसे provide करनी to my underlying operating system, underlying hardware. There's a service. Service part is concerned with my activity framework. So this service part is with the activity framework. How my application will behave to the framework, right? So what are the commands that are needed? What are different resources required? कितनी memory चाहिए? उसको sensor से अगर signal आ रहा है, उसको कैसे signal चाहिए? कैसे मेरा अगर ARM kit है मेरे पास, so मेरी ARM kit को कैसे signal process करना है, so that it gives to the application part, application layer. So services, it's a on the second layer, it's a similar to an activity except it runs in a background without the user interaction. Right? So that is a part of application framework. Example of a service might be a media player that plays music while user performs other tasks. There is one layer of service. There's one part of example of service. Third is broadcast receivers. These are just components. If I want to make my own application, Android-based application for my own embedded system, right? So broadcast receivers, if I want to have my standalone system, Android system, if I want to develop based on Android, or if I want to have network based, like our mobile phones based on Android. I just told you before that Android is not only used in mobile phones. Like if I talk about mobile phones or tablets, they are network based. If I talk about washing machine, Android based washing machine, right, that is being controlled by my own cell phone. There's not a network based. There's only a that can be a standalone or that can be interfaced to one commanding system. For example, microwave oven, another application. Like again, Android based microwave oven, they are already available. Not popular in India, they are available in the market, right? So Android based watches are already nowadays available, right? So whether I need a broadcast, this is the third part now. There's a whether I need broadcast receivers or I don't need that. So it simply responds to the broadcast messages from other applications or from the system on the network or not on the network. For example, it may be useful for application to know when a picture has been taken, right? So it's a when activity has been done, at what time activity has been activated by the user, or a service has been performed. So there's all the broadcast. Internal broadcast is also there. External broadcast is also there. So broadcast receivers, and lastly content provider. If the user needs particular content, उसको कैसे provide करना है, कौन सी वेबसाइट से provide करना है, और internally कैसे provide करना है, so किस memory से data लेना है. So all that is a part of content provider that supplies data, and content provider it's a part of kernel that actually interacts with the hardware. Hardware में कहाँ मेरा data store है in ARM, because basically Android works with the ARM 8051 or you can say PIC or AVRs. They are not nowadays. They are not yet supported by Android. ARM operating ARM 7, ARM 5, ARM 9. That is that hardware is supported by the Android, right? So ARM based, we can develop any embedded system, and we can install Android. So I just told you it's a freeware you can download from the internet. So content provider supplies data from one application to the other on request, and such requests are handled by the methods of content resolver classes, and that are handled, and the data may be stored in a file system or whatever the user requires. So we need to program that कि मेरा data कहाँ पर store होगा, मेरी command कैसे जाएगी, right? All that. So these are 4 components for the application development that is on Android. And ये application development कहाँ करेंगे हम? On Android Studio. Android Studio it's a software that can be downloaded from the Google. I just told you the website. So what we discussed, I just summarize all the lecture. What we discussed at the very first, we discussed the embedded system, the basics of embedded system. Embedded system कहाँ का apply होता है? Nowadays embedded system is available everywhere in all the applications, in all the daily applications we just discussed. There are many daily applications, not in a single devices that is without embedded system, right? Then we have examples of embedded system we just saw. Then we just saw Android system, the basic definition of Android system. It consists of middleware, OS, and kernel part. Then we just discussed all the architecture in detail, the file layer architecture. There's a application framework. Then we discussed core libraries. Then we have runtime, Dalvik virtual machine parallel to the JVM. Then we discussed Linux kernel, where different services which are being provided or which are to be provided by the different layers in the Android. That we discussed in detail, right? Then we discussed the difference between Android platform and iOS, because when the Android was started in 2005, only one operating system was there, right, to support smartphones or to support that functionality, that kind of functionality for which the Android was to be developed. In 2005, there was only iOS by Apple, right? So parallel to that, Android was developed. We just saw the differences. What are the differences? Then after that, how to develop Android-based application from scratch in a lab. Lab में हम अपनी, because nowadays in the labs ARM kits are available, they are in the part of syllabus in a BTech or MTech nowadays in most of the universities. So Android, from the Android kit, I can just interface the simple components, and I can download the Android Studio JVM from the internet, and I can just customize theirs and run my own application. Just I can interface the different sensors, right? So then the different parts, application development components, there are 4 components we discussed. So that is all from my side based on Android. So how to develop an application on embedded system based on Android, because nowadays Android is being used in every application. This is because it provides a very easy interface with the user, right? So that was all from my side. So next is from next 15 minutes. If there are any questions, any doubts, you can ask. Can you repeat any core applications, for example, what you try to say? No, core applications have been, they are proprietary. So this is a core application, but it's a proprietary. Very good. Right. So we need to take the permission, or we need to have an agreement with the Google. Otherwise, as such, no such application there at this time. This Android is a core on the interface. So this is a main actually book that Google has. They have in their. Yes. Right. Right. Applications, in the sense, application means that I want to say that application means interface, right? How to interface with the touch display, how to interface with the actual input output devices, how to interface with the sensors. That kind of driver which are provided by the Linux kernel itself. They are part of Linux kernel itself. They are not part of the actual upper layers which the Android is providing. वो उनका पार्ट नहीं है, सो वो कर्नल का पार्ट है, वो प्रोवाइड करता है. As such applications, they are proprietary. जो बेसिक ड्राइवर पार्ट है वो प्रोवाइड करता है Linux, and Linux is also open source, that we have already seen. So any other query or question? Middleware means the middle part. It can be an interpreter, it can be a compiler, it can be an assembler. So actually when I talk about assembler, I am talking about that my assembly language programming is being converted into machine language programming. That is actually assembler. और इंटरप्रेटर क्या करता है और कंपाइलर क्या करता है? कंपाइलर मेरे C++ को हायर लेवल, यू कैन से हायर लेवल लैंग्वेजेस को मेरा डाउन कन्वर्ट करता है. लाइक C++, for example, we have Keel compiler for 8051. We have Real-View compiler for the ARM system. For the ARM system, we have Real-View simulator. There's a software, there's a Real-View, right? So वो provide करता है. So that's a middleware. So middleware is a common name that is given जब हम ऊपर वाला एप्लीकेशन लेयर निकाल देते हैं और नीचे वाला कर्नल पार्ट निकाल देते हैं, जो मिडिल में आता है वो दैट ऑल इज मिडलवेयर. सो एनी अदर क्वेरी?
Can we have this Android system without touch screen?
Yes, of course we can have, because touch is nothing. Because people, most of the people, we are fascinating about touch screen. Touch screen is nothing. What is touch screen? We need to understand. Touch screen is input device embedded on a output device. So in our commercial screens, input device is different and output device is different. So there's not much difference. But how to handle the data on a display, how to get the input, how to give the output on the display, and how to get the input to the system from the display, on that part is different. Baki rest functionality is all same. So that can we can have different display devices different and output devices different, because display is just an output device. We can talk about any LCD or LED signboards nowadays are there. They are all you can say devices, output devices. Input can be anything, mouse based, keyboard based, or any other joystick based, anything. So any other query?
Thank you, sir. Queries from participants.
Hello.
Do you have any query, please?
Hello. Good evening, ma'am.
Good evening.
We are from PVP SIT.
Yes, ma'am. Please go ahead with your query.
Yeah. What is meant by SDK 86, ma'am?
Okay.
SDK 86.
Yes, yes. SDK 86 is software development kit for 86. 86 is actually 32-bit को हम 86 बोलते हैं और इसमें कर्नल क्या होता है वो x86 means that was name
Yes.
jointly given to the like 8086 based processors. It comes in 8086, 186, 286 and so on to 486.
Okay.
I just remember I just saw first computer in 1992 that was all based on 804 486 microprocessor or it is a 32-bit.
Okay. So how?
जो ये आर्किटेक्चर यूज करता है और सॉफ्टवेयर स्टैक यूज करता है उसको हम 8x86 बोलते हैं और अदरवाइज दैट इज 64-bit.
Sir, how can we interface this SDK 86 with Android, sir?
That is basically hardware difference. Like for example लेता हूँ जैसे nowadays what happens we have laptops, right? So laptops are, let us say they provide 64-bit laptops are there. There's a internal processor is 64-bit. No, जब उसके ऊपर हम कोई you might have experienced जब उसके ऊपर हम कोई सॉफ्टवेयर इंस्टॉल करते हैं which is 32-bit वो अपना सेपरेट फोल्डर बनाता है that is named as x86. अगर हम उसके ऊपर 64-bit सॉफ्टवेयर इंस्टॉल करते हैं वो नॉर्मल इंस्टॉल होता है. Otherwise there are two folders in the 64-bit systems.
One more doubt, sir.
Yes.
What is meant by Dalvik virtual machine, sir? Practically, sir. How can we use that?
Okay. Dalvik virtual machine is similar to the JVM. Java virtual machine क्या करता है? It just provides an environment to the user interface. For example, whenever I play any game,
Okay.
so it provides an environment. वो जो गेम मैं ओपन करता हूँ पीसी पे वो एक एनवायरनमेंट प्रोवाइड कर देता है मुझे. दैट इज अ जावा वर्चुअल मशीन.
Okay.
So we have just discussed that in very much detail. That is DVM. So that is parallel to JVM. So ये DVM क्या करता है? For example लेता हूँ जैसे मेरा विंडोज ऑपरेटिंग सिस्टम क्या करता है? इट प्रोवाइड्स एन एनवायरनमेंट. ये डेस्कटॉप प्रोवाइड करता है और डेस्कटॉप के ऊपर जो भी मैं एप्लीकेशन खोलता हूँ वो डेस्कटॉप के ऊपर खुलती है. Similarly, so my DVM provides an interface to my Android system. So ये एक टूल प्रोवाइड करता है, ये एक इंटरफेस प्रोवाइड करता है और उसके बीच में all applications are open and all resources are allocated. The different requirements, applications might have different requirements. तो वो सभी DVM handle करता है. That is a runtime. This is a runtime actually.
Yes, sir. Thank you, sir.